In this unit, we're going to look at organic chemistry. Now, organic chemistry is quite a big area, so I thought it would be a good idea just to have an overview of what we're going to look at. So, organic chemistry is based around the chemistry of carbon, which is in group 4 of the periodic table and has 4 outer electrons in its outer shell. Now, because of this, carbon tends to form covalent bonds, and it is its ability to form these covalent bonds with both itself, for example, like that, and other elements, particularly hydrogen, that can lead to the formation of molecules with long chains, including even longer molecules called polymers, which give rise to literally thousands of different substances. Okay, so just emphasizing that, carbon forms covalent bonds with itself and other elements such as oxygen and the halides, and this can give rise to many different substances. Now, we're just going to have a look at a handful of those. Okay, so let's just have a quick review of the 4 families that we'll be looking at. And the first one in the top left here, you've got some methane gas coming out of an oil well. It's burning off there, and methane is an example of an alkane. Notice that's ANE. We will talk about the naming systems in all of these different families in later units. Okay, so you've got methane and propane, and this is the structural formula of propane, and its chemical formula will be C3 and H8. Now on the other side, we've got a family called the alkenes as opposed to alkanes, all right, of which ethene is an example. Now, okay, so alkenes are like alkanes, but they have a double bond present in their structure. Okay, also made from just carbon and hydrogen. So the formula for ethene would be C2H2, and another group that we'll be looking at will be the alcohols, one that you're probably familiar with because ethanol is a member of the alcohol family, and ethanol is found in wine. So this is again a hydrocarbon molecule but with an oxygen atom thrown in here. So the formula for ethanol will be C2H5, and then you have this OH group, and we will also be mentioning a little bit about things called esters. I won't write out the structure formula for those, but esters are also present in wine. Those are the things that make the wine smell nice. Yeah. And lastly, we'll be looking at what we call carboxylic acids, of which vinegar is an example. Vinegar contains a substance called ethanoic acid. So ethanoic acid is a member of the carboxylic acid family, and that is formed actually when ethanol becomes oxidized and it changes into vinegar. So if you leave a bottle of wine open exposed to air for a long period of time, it will eventually change to red wine vinegar. So there's the structure of ethanoic acid. You see you've got a double bond here, and you've got this OH group. And notice that the number of bonds on the carbon atom is always going to be 4. Okay, so you've got 1, 2, 3, 4 on that one, and then you've got 1, 2, 3, 4 on this one. And so the formula for ethanoic acid will be CH3, and then CO and OH. Okay, but we'll be talking about these families in detail in the following lessons. This is just really an overview so that you can see what we're going to be doing. Finally, we will also be looking at polymers. Polymers are very important substances, so we need to look at those. When we say long chains, these are really long chains of molecules formed by connecting what we call monomers. All right, so they're made from monomers. That's the unit that makes up the polymer, of which ethene is an example. So an example of a polymer is polythene. We've just mentioned that, which is used to make plastic bags, for example. So we'll be looking at polymers. Okay.